Hello everybody and welcome to our webinar today here at Fronius. Today we want to take a closer look at how to control multiple PV-Genset solutions with DEIF components. I quickly want to introduce the team for today. My name is Christoph Schillinger. I'm from the team Trainings and Education here at Fronius. I will guide you through the Fronius part, and on the other communication line today is online Ellen Schmidt from the Danish company DEIF. Hello, Ellen, and welcome.
Hello, Christoph, and thank you for inviting me to help on this webinar today.
All right, so Ellen and I will do the presentation today, and I quickly want to show you the agenda, what's happening today. So we will take a closer look at why PV-Genset anyway, what's the reason, what's the benefit, a closer look also on the Fronius PV-Genset easy solution. So there is a way to have a Fronius solution, but only for a single genset scenario. Then we go into detail on the DEIF solutions. This is where I want to switch to Ellen for introducing us in this topic. After that, we quickly want to go back to Fronius. What are options for the wiring? Which settings need to be done on the Fronius components? And last but not least, a short Q&A session where also you, the audience, can ask questions, of course. Quick note before we start, you can, of course, also do it during the webinar. If you have any questions, just use the chat box on the right side of your screen. Send your question through and we try to answer the questions as good as possible. So then, why PV-Genset? So there are a few topics, a few benefits why a mixture, a combination of a diesel generator and a photovoltaic system is beneficial. The first one, of course, it's a global issue right now. The cost for the PV system is annually decreasing by an average of 10%, let's say. So it's becoming more and more beneficial to use such systems in combination. The second, of course, is that the fuel costs for these gensets are steadily rising. So this is the reason why we have a very profitable investment, and it's becoming even more profitable. If we look on the schematic on the right side, we can see the scissor in this case is becoming wider and wider, and the savings are much higher year per year. Yeah, of course, there is the topic with the independency. Usually such systems are placed in weak grid regions, or even if there is no grid available. So with these systems, they're independent, and with adding a PV on it, we are more independent in terms of diesel delivery or fuel delivery. Yes, scalability is also a big topic. It's suitable for different sizes, multiple kilowatt systems up to megawatt systems also. And also it's a retrofit solution, which is possible, which we later hear then from Ellen. There are some DEIF solutions for this retrofit. Yeah, now I quickly want to present you some use cases where it is usually used. Of course, utilities, as I mentioned, off-grid or weak grid regions where we have a very unreliable grid security. That's a usual use case. Remote industries, of course, where we have heavy consumers in mining industry, oil and gas drilling. It's also very common to use. Real estate, of course, if we look at office buildings, logistics, and so on. And there is a variety of other applications like hotels, resorts, and also bigger agricultural systems where a PV genset is beneficial. Yeah, on the other side, of course, there are some criteria. I quickly want to go through them. First of all, we need to make sure before installing it, such PV genset solution, that we have an accurate system design. What I mean by that is that we need to make sure that the genset itself, the generator, provides the baseload, the power for the baseload 24/7, if we're talking about the off-grid solution. Reason for that is that the Fronius inverters always need some frequency and voltage to reference to, and of course, therefore we need some reference. It doesn't matter if it's coming from the grid or the genset, but we need to make sure that it is an accurate design. Second point is the sufficient space for the PV plant. Usually we recommend only to do systems above 50 kilowatt peak. Below that, of course, it's also possible, but not very economic, let's say. Yeah, the third point is regarding the fuel costs. Of course, the higher the fuel costs are, the more it makes sense to do a PV genset, because we do an active saving of fuel, and therefore the OPEX costs of the whole system are going down. And last but not least, the green thinking is becoming a major role. We have a good possibility to reduce CO2 emissions with this solution, and of course we can see it globally. This is a big issue. Yeah, I quickly want to show you just a typical load curve of a PV genset solution. We can see here the gray line, the load profile of an example load. As we can see, it's providing, we have it over the whole day, and in the red line we have the PV production curve during the day. With the light gray area, we see then the energy that is provided by the diesel genset, and here we can see it's providing the whole base load for the system also during the night. In the darker gray area, we have then the energy that is supplied by PV, and therefore also the active fuel saving that we have. So we can see here that during the day we have a big amount of energy saved, so fuel saved and taken by the PV. Yeah, quickly want to take a look at the compatible Fronius inverters. Actually, you could use all snap inverters for such a system, but when we talk about bigger systems and economic reasons, I've only showed you here these two, the Fronius Simo 10 kilowatt to 20 kilowatt and the Fronius Echo 25 and 27, because with these two we have the usual commercial sector supplied, and actually we can combine them in systems. So with the Simo we would have a very flexible inverter for difficult shadings, difficult rooftops to build on, for example. And with the Echo we have a very cost-effective inverter, and in combination we have a very optimum way to design a PV system. Both of them are able to set up the microgrid 50 or 60 Hertz, depending on the region or the country we want to install. Yes. So yeah, then I quickly want to show you the previously mentioned PV-Genset easy solution. Here we want to talk about a single generator. If this is the case, it would be able to use the Fronius PV system controller, which we can see on the right side. The system controller is doing nothing more than measuring on the feed-in point or the energy flow within the whole system. And it is also connected to the inverter via Modbus and is according to the energy flow within the system regulating the inverter output power. So if the generator would come into the scenario where it would run underneath a certain efficiency power, the controller would regulate the inverter down to a percent where the inverter can run in an optimum manner. The generator can run in an optimum manner. But we will come into detail on this a little bit later then. Yeah, quickly want to again tell you about the core components and the use in the scenario. So the main task for a PV-Genset control, so the reason why we need it, is actually to protect the diesel generator itself, because this is the core component, as we previously mentioned. And to protect it, it has to be controlled. The inverter they have to be controlled, and this is done by regulating the PV power. So underneath we can see here this schematic. With the blue line we can see the load profile, and then we can see a sudden load drop. For example, a heavy machinery is switched off, and in the red area we would see the available PV in the dotted line. But because we need to make sure that the minimum genset load, the gray line, is not exceeded down below, we need to cut down the actual PV power. So this is done in milliseconds. It's a very fast regulation, and therefore it's the genset will not run underneath a certain efficiency level. This is done then by the control. Okay, so before switching over to Ellen for the presentation, I quickly want to mention what we will see now in the next slides. Ellen will be talking about the advanced and professional solutions. What is the difference actually? With the advanced solution, we have all the benefits that we have with the easy solution, but now it is possible to serve more complexity regarding that we can have multiple diesel generators within the system. It can be retrofit, so it's not dependent on the manufacturer or the brand of the diesel generators. We are also independent from the voltage level, can be low voltage or medium voltage, whilst we have on the easy solution only the low voltage possible. And yeah, the overall benefit is then that we have more, that we can serve more complexity. And a step forward is then the professional solution. The difference which we can see here is then that we have all the benefits that we have with the advanced, but now every diesel generator within the system has its own automatic genset controller. And therefore we have a communication between the components for regulating the system on eye level. So all the DEIF components are communicating on an eye level, and therefore it's the ultimate solution for power management. So if we're talking about the new solution, not a retrofit, this would be the perfect solution then. Okay, so one last slide. What are then the requirements for a controller, a genset controller? It doesn't matter if we talk here about the Fronius PV system controller or the DEIF solution with the ASC4 solar controller. They are doing the same thing, regulating the PV power. In the red dots, we can see here the system controller from Fronius. Yeah, we have here only the possibility to regulate one diesel generator. It's communicating with the Fronius inverter, and that's the one thing. With the blue dots, we now can see the DEIF solution. Yeah, both of them are possible to do a grid backup. It's optional also for Fronius. Also, both of them are communicating with the Fronius inverter. But in this case now, with DEIF, we are able to serve multiple diesel generators and therefore more complexity. Okay, now that's the line for me. So I will now switch over to Ellen. And he will continue with his presentation then.
Yes. And first thing, I want to hear if you see my screen.
Yes, looks good.
All right, then let us begin. Yeah, so we have been making this presentation. It is a sum up of the general questions we get. We have focused the PowerPoint mostly about this, and this is focusing around the application, in the main functionality, inverter main functionality, the design of the application, and general setup parameters, and a little bit about the commissioning also. So it's mostly about the questions that we typically get. If we look at the beginning of the presentation, or the product era, we have launched it back in June 2016. We launched it as a PV diesel solution, a PV diesel utility solution. Now we also have the possibility to serve storage, but today it is about the PV diesel solution. We have made plants from all the way down to 12 kilowatt, and the biggest is at the moment 10,000 kilowatt. But you can say our average size is at the moment close to 500 kilowatt PV power. So that's the picture that you can get. If we should point at some main functions, then I have listed a couple of main functions here. And number one main function is, of course, the minimum load on the generator or engine. Actually, we need to be able to maintain the minimum load, as Christoph also mentioned. This is a key essential for the health of the engine, to avoid problems with glazing of cylinder liners, for instance. We have export requirements, zero export requirements also when you are grid parallel. Typically, zero export is a must. That is seen in the majority of the grid-tied applications, but we can also set export set point depending on your agreement with the utility company. Then we have points 3 and 4. This is for the flexibility, for the scalability. This is always an important point for DEIF. We have use single or multiple mains feeders, and of course single or synchronizing generators. Our strength is probably when we have the synchronizing and multiple feeders and generators, where we can step from the Fronius Easy solution to Fronius Advanced or Professional. Also important main functionality is the spinning reserve functionality here. We can adjust this. There are 3 strategies. We'll see at least 2 of them later on in the presentation here. If we look at the inverters, one AC controller usually we say it can control 32 inverters. This is because you have a Modbus line, and typically the Modbus limitation is 32, but this is there are ways to overcome that, but just as a general rule of thumb, 32 inverters per ASC. The P and Q control is of course the most important functionality that we have. We need to control the curtailment in order to control the set point of the plant. At the same time, we have the generator power factor control. We'll see later how we do all these things. Control strategies also when we have generators and inverters working together. For a little bit specialized applications, we can limit the power of the inverter in order to produce more reactive power. This is if you have comparable small generators to compare with the inverters, and some control strategies there. Irradiance sensing is important, at least in some areas. This depends on where you are in the world, but you would need them to calculate the curtailment. Counters is actually also available for all the production, whether it's a PV, generator, mains, and of course the curtailment. And then you can control from utility company side if you have a box which accepts variable control, or you bring in external control. If we move over to the actual solution, here's just one example that I've drawn. This is the Fronius advanced solution. This is the retrofit solution for multi-generator systems. I have shown in the picture 2 generators, 2 utility incomers, and there is limitations here, and this is 16 mains feeders and 16 generators. This is the limitations when you use advanced. We measure the power sources. You can see on the sketch that we have digital power meters, one on each power source, and this also means we always know how much we import, export, or how much power the generator is producing. This way we can handle the generator minimum load control. An additional advantage is, of course, you have the generator power protection, reverse power protection, so you don't need to buy additional reverse power protection relays if you have this system. Zero export control and mains power export control can be performed because we have the measurements of the mains. Here we can see that with the advanced solution, just to note, the utility incomers, this is summed up. So it is the sum of the export or import that is the actual set point. So if you export 50 on each utility feeder, then your total export is 100 kilowatt. So if your set point is 100 kilowatt, you are in balance. In terms of spinning reserve, then we don't actually handle this because, as you see, we don't control the generators. We control the PV inverters only, but since we measure all the power sources, we can give you spinning reserve warnings. So you have different levels of spinning reserve warnings. And these warnings, let's say you have less than 30% or less than 10% spinning reserve, that is something you can use in your application. So maybe trip some load or start additional machinery. Notice with the advanced solution, it is ideal for quick deployment in brownfield projects or retrofit projects. It uses the existing controllers, so whatever you have on your generator, this will remain in place. Also, the protection remains in place. This means the automatic sequences that you have already in your existing system, this is the same that you have after the installation of the PV. So this is one of the reasons why it's very fast to install, and you only have to focus more or less on the PV side and then install the measurement equipment. It's a little bit different when you look at the professional solution. Here we have limitations as well. It's up to 32 mains feeders, 32 generators, or a combination of them, of course. So instead of 16 now you can make bigger plants. But it is a fully integrated solution for multi-generator systems. So you have the full backup, you have all plant modes available. This is for backup power, critical power, rental power, prime power. So this is the complete solution where everything is controlled by the DEIF. Talking about the controller types, the controllers I have on the generator here and on the utility incomers, this is the so-called AGC4 automatic generator controller version 4. We have also other controllers, ADC 150 and ADC 200. So just notice that we have different variants that you can use. You get, of course, the full power management functionality. You get also generator protection, synchronizing of all breakers. You get load sharing and automatic generator start-stop. So all your power management features is available with this solution. Engine safety start-stop, fuel optimizing, priority rearrange, and you can go on to even further detailed functionality like ground relay handling and load shed functionalities as well. But we have complete AGC webinars, power management webinars, where in depth we'll go through all of the power management functionality. I have made this slide. It shows a little overview so you can see what you actually get with the different solutions. So Fronius advanced solution, this will of course give you inverter control. We can see on the upper square or upper box, you have the active power control, reactive power control, and this is of course the most important. Closed loop functionality is available, meaning that the system compensates itself if you have a dropout of an inverter or something fails. Then we can say other factors like counters, possibility for monitoring your sensor inputs. This is key elements for the inverter. But if you look at the engine/generator on the lower left side in the box there, you can see we have power factor control and minimum genset load. All of this is controlled by adjusting the PV inverter. Of course, counters, we had the overload and reverse power trip that I mentioned before, bar sharing, and your spinning reserve alarms. And for the utility incomer or utility feeder, you have power export mode, zero power export mode. This is available, and of course you can control it with set points directly or from inputs. The Fronius professional solution looks a little bit different. Actually, what you can see is that the upper square is the same, so it's still what you get is the active power control and reactive power control, closed loop, and so on. But you can see that you can see that you have full power management functionality. So on the generator side, you have a lot more functionality. You have the same as before, the same as in the Fronius Advanced, but here you also have power management, failure handling, application failure handling to a wider extent. You have multi-master functionality, priority handlings, synchronizing protection. In addition, also to this, you have the full J1939 implementation to the engine ECU. So there's a lot of power management functions that you get, which is possible. But for the utility incomer side, you have the plant control for all the islanded modes and the grid-tied modes, and it is in this case it is the plant control where we can actually react when something happens. With the Fronius Advanced, it was only set point control, but here, if you have like a mains failure, the DEIF system will start the gensets. When the gensets are running, PV inverters will reconnect, and you will be running off-grid with the PV inverters and the gensets. When the when the utility returns, you will synchronize back to the utility, or do a black changeover if needed, and then the PV inverters will be controlled up against the utility. So you have the full package here of the plant control. Also, you can note the mains protections available. So this is the key difference between the advanced and the professional solution. How large level of control that you actually get. Let's see a little about how we do this. If we look at the main points, we can say minimum load of the generator. Which settings do we have? How do we do it? And we have two settings: minimum load DG level 1 and level 2. And if, like the drawing says or shows, you have two generators, generator 1 with a minimum load of say 30% and generator 2 with a minimum load of 40%, if they are non-synchronized, you can swap between set 1 and set 2, and then they will run at their own optimal load, minimum load. To note, if you have a synchronized system, it's a compromise, then you have to set one shared minimum load. But you can see with the settings, you can toggle this, or you can do it automatically. Here you see a picture of our small programming tool. We call it mLogic. It is a small tool with 3 input conditions, and then you will drive an output. And here you can see I use one input condition. Generator 1 is connected. That will set minimum genset load set 1. Or if Gen 2 is connected, it will set minimum genset load set 2. So this way it's an easy swap between the two, and the controller does all the work. At the same time as the minimum load, it's important to look at the generator power factor. So here we have settings for generator power factor. Our default setting is 0.8 to 1. This means that the generator will be running between these outer limits, and will actually force the generator towards the minimum level, so 0.8 in this case. This is because we want to produce as much renewable power with the inverter. So if the generator is loaded beyond the setting 0.8, let us say you add some load, so the power factor drops to 0.75, then the inverter will produce reactive power to push the generator back to 0.8. So that is how we do the power factor control. So you can avoid some, let's say you have some warranty conditions or operating conditions, or you just want to look for the most optimal point for the generator. Then you have this possibility. You can see the minimum 0.1, so you can turn it off also if you want to. Other questions we get is also about how we configure this. Application configuration, as we call it. You can see the picture of our programming tool, the utility software. This is a tool where you design the plant. And now for the advanced solution, I have a mains incomer, a mains breaker, the PV breaker, and then at the bottom you can see it's a symbol of some panels, but it is the inverter installation that you have there. On the advanced solution, since it is not a fully integrated solution, then you can't see the generators here. This is configured on different screen, so it looks like this. If you have 4 generators, as the example shows, then you will simply go into the I/O settings and decide where do you want to connect the breaker position feedback. So in this case, it's on terminal 43, 44, 45, and 46. So with these inputs, we'll tell the ASC now generator 1 is connected, or 2, 3, or 4. So it is doable, definitely. We see applications also where there's a large distance maybe, or just because it's easier and less expensive. But let's say your PV installation is on the roof, your generators are located in the basement, so you have some distance between them. So you can run a Modbus cable from the power meters. So in this case I have 4 generators with power meters. I run Modbus to the DEIF controller where it is located. And then it's also practical, as you can see, to wire the generator breaker position into the digital power meters. So the idea is in mLogic you just set up, for instance, in logic 1, diesel generator power meter 1. That means generator breaker 1 is closed. And the red square means diesel generator power meter number 2, the second power meter. This means generator 2 is closed, and so forth. So this way you can, in an easier way, just with a Modbus cable from the basement to the roof, get to know all about generator power and position status. On the professional solution, it's a little bit different. In the new applications, it's a fully integrated solution. All controllers, they communicate with each other. So this means they can see each other, basically. And everything is drawn in the same application configuration. So in some way, it is easier. And here I just want to show that you can actually, in a flexible way, configure your application. I just show 2 utility incomers, 2 points of connection for the solar, the same 4 generators, but now separated with bus tie breakers or bus couplers. So it's just to show that you have several possibilities to create your application. I mentioned earlier the spinning reserve. Spinning reserve is a power management functionality, so for the integrated solution. If we talk about the dynamic spinning reserve, then we reserve a portion on the generator, so the generator can always supply this amount of power. So let's say our set point is 50%. Then if the PV is producing 100 kilowatt, 50% of this, that is 50 kilowatt. So the generators can always provide additionally 50 kilowatt. And maybe during midday you produce 500 kilowatt of solar. So now they will reserve 250 kilowatt. So you see, it's a dynamic value. This means that it will start and stop generators according to the PV production in order to minimize the risk of a blackout, of course. If you don't want to use this, there are other ways, but it is a possibility where you can set the dynamic level. The other possibility is the forecasting, short-term weather forecasting. Here it's a possibility where you have a sky camera sitting on the same installation as solar, and it's monitoring what is going on the sky. So cloud movements, how dark is the sky, and so on. And then it will automatically adjust the number of generators that's running. So basically you want to start and stop generators before something happens to prevent your system against a blackout. We have implemented two systems in our ASC controller that you can see on the left hand side. When we connect to the sky camera, then we'll know that in X amount of time, this is a horizon between 1 and 60 minutes, then we'll lose a number of kilowatt. So let's say you lose 600 kilowatt in 15 minutes. The system is okay with this. It doesn't do anything. But when the clouds get closer to the actual site, we know now, okay, in 1 minute you lose your power, and then we'll start generators. So you optimize the time that your additional generators are running. And of course the stop is also working based on time. So you can stop a couple of minutes after the clouds has disappeared one more time. So this is how it's working. The third strategy I mentioned is the spinning reserve of the storage system. But this is another presentation. Communication is key essential if you look at PV diesel solutions or communication with inverters. So in this case I have Modbus communication shown as the red line, and of course DEIF controller communicates with the Modbus to the Echo in this case, or SIMO. So this is traditional IS-45 Modbus. You can see on the upper side we have 3 controllers shown. This could be 3 generators, it could be a utility incomer and 2 generators. And now I have shown DEIF controllers. This means they will communicate on the blue line, our proprietary protocol. And if it's third party, so for Fronius advanced solution, we would install energy meters, and then it would be another Modbus line that goes to the AC controller. So it's separated line, the control for the inverter and energy metering. Then you can see lower we have 4020 milliamp and P100 inputs for irradiance sensing and other. So when you set up a Fronius system, it's a SunSpec implementation. So what you do is you select the SunSpec protocol, generic SunSpec. It's a broadcast type, so we send to all of the inverters at the same time. And Sunspec uses a single register implementation. You don't need to set that. So this is the setting that relates to the specific Fronius inverter. So here's an overview picture of the energy management. Utility incomer on the left-hand side, that's the ADC mains. We have the plant control, set point control, import, export, of course, is a possibility. Also grid stabilizing features in the ADC mains, and synchronizing and breaker handling. The next controller is the genset controller, AVR control for voltage regulation, speed governor control. We have the full ECU communication and synchronizing and control of breaker, along with the other functionalities I mentioned. And for the photovoltaic system, of course, the PEQ control is important with the inverter communication. Control of breaker. If you have a breaker there, we close the breaker from the AC solar side, and can of course also trip it. So as soon as the bus voltage is live, then we close the breaker, and now your inverters can reconnect to the system. And to complete the energy management system, we have the storage integration with the PCS communication and BMS communication on the right-hand side. When you do commissioning, you have to follow some steps. We have made a commissioning manual. It's a good idea to look at this, because there we have some chapters where we kind of go through what you need to do. So you can see it starts pretty basic. Create an IP list of all devices, create a list of power meters, ID number, baud rate, settings, other things like power source data. So the fundamentals that you need to know. And then you can work your way through the commissioning manual. Usually it works pretty well. This is a generic manual, so it covers both the advanced and the professional solution, and there are some deviations there, but it will take you a large step of the way. So on our website, you can go to the AC4 page. Today you have to select the land power and AC4, and then under the documentation you can find the commissioning guide. This is really helpful and done most of the times. Then, Christoph, the last slide that I will show here, this is for the AC solar, a case, just to show what it could look like. This is a Fronius advanced setup. You can see we have a couple of inverters, the Fronius inverters Eco that is set up. It's a 250 kilowatt system from 2018, and it is in Pakistan, this precise system. And you can see the AC controller in the cabinet. The display is not installed yet. It's lying in the bottom of the cabinet. So it's a fully working system. All right, Christoph.
Okay.
I think we should carry on with your slides, final slides here. We have about 10 minutes left.
All right. Then I will quickly want to change the presentation one more time. So now the question that you asked previously, again, can you see my screen?
Yes, it looks very nice.
Perfect. Then we will continue with the last part, and after that, a short question and answer session. So, yeah, thank you, Alan, so far for introducing us into the DEIF topics, the DEIF components. Now I quickly want to show you some wirings and some examples, how you can do that and what to look out for. So what we can see on this picture is the actual Modbus RTU communication between the Fronius data managers and the controlling. So can be either the PV-Genset controller from Fronius or the ASC4 Solar from DEIF. It's connected via Modbus. And what we can also see is that above the data managers, we can have, so there is symbolized multiple inverters. So when we look at a bigger system, we tend to do, to cluster, let's say 5 to 10 inverters into a solar net ring. So a Fronius communication between the inverters, and per Fronius inverter cluster, we have then one data manager, and then these data managers are connected via Modbus in this case. So by doing this, we are having less risk if a solar net ring is failing, or if there is any disturbance, that not the whole PV system is shut down, but only a portion of this system. Yeah, when looking at the cabling down below, we can see a twisted cable pair. So that is the first thing I want to recommend you. Please use a twisted cable pair for the Modbus communication. So between data plus and data minus, these should be a twisted pair. Also, we can see a grounding that is done. So in this area underneath the controller, we can see that the shield of the cable is grounded on one side, which is again a way to ensure the perfect data communication. Then another part is what is written down left. Switch every data manager to master. That's essential to switch them to master, because only then the data will be sent to the controller. And last but not least, we don't forget the termination at the end of our Modbus bus line. So we have a 120 ohm termination resistor, which we need to set. So looking at this Modbus line, we have on the left-hand side on the data manager an end point of our Modbus. So here we need to set the termination to on. There is a little dip switch above the antenna. Here we have then the ability to switch the termination to on. In the middle data manager, we need to set it to off. And again, end of our Modbus line is then on the controller in this case. And here we also need to set the 120 ohm resistor. So we need to make sure to do this. And in this case, then we have the perfect communication. So one last thing I want to mention is the failsafe mechanism. That's related to the slide we just saw. Why did we do the clustering of the SolarNet and Modbus? If the Modbus is failing, the communication line is broken, something happened, the inverter will run on a fallback value, which I can set. I will show you in the next slide. The same applies to the SolarNet ring. If anything happens in this SolarNet cluster, in this SolarNet ring, the inverter will run on a fallback value, which I can set. So now the question, where can I set this? For the Modbus, we have the ability to set this on the web UI. So we can open the Wi-Fi access point on the inverter, connect to it via tablet or laptop, and then we come to the settings where we can do this, the controlling priorities. And here we want to set it like the following picture. The controlling the Modbus should be on top, and then we can decide, for example, the first thing, dynamic power reduction. So if the Modbus communication is lost, the inverter would run on the following settings. Down below we can see it. So we have a 20 kilowatt peak inverter in this case, and if the communication is lost, it should run on 1% maximum, so it will only feed in 200 watt in this case. So to make sure to not produce too much power in case the diesel generator would run on an inefficient level or would be in a dangerous level of running. The second option which we can set would be the I/O control. So this is also on the web UI which we can set. So here you as installer, you can decide, do I prefer dynamic power reduction or I/O control. Here we can also set an active power to 1%. So if the Modbus communication is lost, we again would only run on 1% of the maximum power we set earlier. So yeah, then there is the topic with solar net ring. Same but different, of course. This time we aren't able to do this on the web UI. Now we have to set it on the display of the inverter itself. On the inverter display itself, we have the option to enter a service code, let's say. There are 4 buttons down below, and by pressing the third one from the left-hand side 5 times, we can enter then an access code. We have the access code for the professional menu, and to get this code, you have to contact Fronius tech support. They will get you the code, and then we have the following steps. We have also a guideline online for you. There are a few steps where we can select failsafe. So if the solar net is disturbed or broken, the inverter would again run on the fallback value. Okay, so one last slide here. What are then the following steps for you as installer to do, or as system designer? You can send in a checklist to Fronius, also to DEIF, of course. By doing this, we can first of all give you a service report. If it is a multiple diesel generator system, we forward this to DEIF, of course, so that they can then apply the system. Then by installing or commission the system, the only thing we need to do on the inverter itself is to set the microgrid parameter. So by installing it, there is the point where we can set then microgrid 50 or 60 Hertz. This we need to do. And then there is the option to commission the data manager, of course, which we saw earlier by this Modbus communication. By following the Solar Web Wizard, so commissioning the data manager is in this case the same as the Solar Web Wizard. By following the Solar Web Wizard, we can also bring the system online. We can register on Fronius Solar Web. This is our visualizing tool, and by doing this, you as installer or the plant owner has the optimal analysis of the system. We can do an easier service, and we can now access a few warranty benefits also. Yeah, okay, I think this is it for now for the presentation so far. So now I've prepared a few questions, and I would say I quickly go through them with you, Ellen, if this is okay.
Absolutely.
After that, we can see if there are any questions from you, from the audience. So maybe we start with the first questions. Alan, where do you see the highest potential for such PV-Genset solutions? So in geographical manner.
What we have seen until now has, of course, been Africa and Middle East has had large interest. This is also in India, Pakistan area, where we have probably also seen the highest interest. We have requests that's coming in from worldwide level, but it will be India, Pakistan, plus the Middle East area where we have until now had the highest sales.
All right. Okay. Perfect. So the second question would be, what is actually the process for inquiries at DEIF? So what do you do when you get an inquiry? What are the steps, let's say?
When we get an inquiry from a customer, then we'll of course look at what is his request. We would ask typically or / always for the single line or one line diagram just to see what it looks like, which breakers to control / not to control, where's your evacuation points for the PV and so forth. And then we can, based on the description, decide what is the requested functionality. Thereby determine, is it advanced or is it professional, or which kind of solution do you require. So this is the typical process that we get a technical inquiry, and depending on the degree of technical questions that you have, then we dig into this.
All right, I see. Okay. Yeah, one last question remains. I think we already answered this during your presentation, but just to answer it again, how many data managers can be actually connected to the ASC4 solar in this case?
At the moment, we say it's one data manager, or this is the limitation we have at the moment, and this is what we have tested. So that therefore we have this requirement. But then you can say you can hook up many inverters to the data manager. I think it's up to 99.
Yes,
inverters.
correct.
You have a large possibility to control through a single data manager as well. And in terms of inverters directly from the ASC4, it's, yeah, as mentioned, 32 on a Modbus line, unless you begin with Modbus repeaters and extenders.
Yeah. Okay. So yeah, as you mentioned, it is possible to connect up to 99 inverters to one data manager. So there is no problem also for bigger solutions. And yeah. Okay. So I quickly want to check if there are any questions from the audience. So there is one question. Maybe I quickly want to read this. Is it possible to implement the advanced solution with power meters so that later can be upgraded to the professional solution? So adding HEC controllers one by one, let's say.
Yeah, that is that's of course a process you have to go through, but it's typical that you implement the advanced solution, and then you can stepwise work your way through to the professional solution if the request is there later. I think it's a question we can say it can be done, But of course, in the process, when you switch from advanced to professional, you will have to run the system as an advanced, because let's say you have 4 generators and you install power meters on all 4 generators, and now you are in the process of upgrading to professional. Then when you install the first DEIF controller on generator 1, the Modbus line will go to this generator. So we just read power, breaker status and reactive power from the AGC controller. And then when you have all 4 controllers changed to AGC, then you can swap over to the full Fronius professional solution. So that will be the process. So you can do it, but until all is in place, you are kind of like working in a Fronius advanced method.
All right. Okay. So I think we will end the presentation at this point. So which means we will still be online for you, dear audience. Ellen and I will just turn off our microphones, and we will go into the chat for answering your questions that remain. And yeah, at this point, I want to thank you, Ellen, very much for attending, for taking time to do this webinar together with me.
Yeah, thank you. That was my pleasure.
Yeah, and thank you to the audience for joining in and listening. And yeah, as I mentioned, we will now turn off the microphone, and we will be still online for you. Thank you very much, and see you next time. Goodbye.
See you next time. Bye.